According to the National Electrical Code Section 300.13b, receptacles cannot be used as splicing means for electrical conductors. Receptacles are designed to provide a convenient and safe connection point for electrical devices, and they are not intended to be used as junctions for splicing wires together. Using a receptacle as a splicing means can create several safety hazards. Firstly, loose connections where receptacles are not designed to securely hold multiple wires together, increasing the risk of loose connections and overheating. Secondly, overloading where adding additional wires to a receptacle can overload the circuit and exceed its current carrying capacity, potentially leading to electrical fires. And thirdly, electrical shocks, where if the wires are not properly connected, they can create exposed points that may result in electrical shocks. Outlets have multiple terminals to accommodate the different types of connections that may be required, such as supply terminals with brass screws for connecting hot and neutral wires from the power source, load terminals with silver screws for connecting hot and neutral wires to the electrical device being plugged in, and a ground terminal, which is a green screw for connecting the equipment grounding conductor or EGC. While it may be convenient to use these terminals for splicing wires, it is strictly prohibited by the National Electrical Code. Instead, use an approved splicing device such as a wire nut, crimp connector, or junction box. A junction box provides a safe and code-compliant enclosure for making electrical connections. It protects the connections from physical damage and environmental factors. Inside a junction box, electrical connections must be secure and insulated using method approved by the National Electrical Code, such as wire connectors, also known as wire nuts or crimp connectors. Firstly, wire connectors are color-coded plastic caps with internal threads that twist onto stripped wire ends, providing an insulated and secure connection. Secondly, crimp connectors are metal sleeves that are crimped onto stripped wire ends using a specialized tool, creating a permanent and reliable connection. The National Electrical Code mandates that all electrical connections must be accessible for inspection, testing, and maintenance. Junction boxes must be installed in locations that allow easy access, and the covers of junction boxes must remain accessible without requiring the removal of any part of the building structure or finish. The National Electrical Code provides specific guidelines on box fill, which refers to the maximum number of conductors, devices, and fittings that can be installed in a junction box. Box fill calculations ensure that the box is not overcrowded, which can lead to overheating and other safety hazards. The National Electrical Code requires that all unused openings in junction boxes must be closed with appropriate closures such as knockout seals or plugs. This prevents the entry of dust, moisture, and other foreign objects that could compromise the integrity of the electrical connections. When working with electrical wiring, it is essential to follow all safety precautions and wear appropriate personal protective equipment or PPE, such as safety glasses and insulated gloves. Always disconnect the power supply before making any electrical connections, and use a voltage tester to verify that the circuit is de-energized. When selecting wire connectors for a particular application, it is important to consider the wire gauge, the number of conductors, and the environmental conditions. Wire connectors are available in a variety of sizes and types to accommodate different wiring configurations and applications. When installing wire connectors, it is important to follow the manufacturer's instructions carefully to ensure a secure and reliable connection. Over-tightening or under-tightening wire connectors can compromise the integrity of the connection and create safety hazards. When crimping connectors, it is important to use the correct crimping tool and die for the size and type of connector being used. Improper crimping can result in a weak or unreliable connection. When working with aluminum conductors, it is important to use connectors and splicing methods that are specifically designed for use with aluminum. Aluminum conductors can corrode when exposed to dissimilar metals, which can lead to loose connections and overheating. The National Electrical Code requires that all electrical work must be performed by qualified and licensed electricians. Working with electricity can be dangerous, and it is important to have the knowledge and skills necessary to perform the work safely and correctly. In addition to the National Electrical Code, many states and local jurisdictions have their own electrical codes and regulations. It is important to be familiar with the applicable codes and regulations in your area before performing any electrical work. Electrical inspections are typically required for new construction, renovations, and other electrical work. Electrical inspectors ensure that the work is performed in accordance with the applicable codes and regulations. Grounding is an essential safety measure that protects people from electrical shock. The National Electrical Code requires that all electrical systems must be properly grounded to provide a path for fault current to flow back to the source. Grounding conductors must be sized appropriately for the size of the circuit they are serving. The National Electrical Code provides tables and guidelines for sizing grounding conductors. Ground fault circuit interrupters, or GFCIs, are devices that protect people from electrical shock by detecting ground faults. The National Electrical Code requires that GFCIs be installed in certain locations such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FCIs, are devices that protect against electrical fires by detecting arc faults. The National Electrical Code requires that FCIs be installed in certain locations, such as bedrooms and living rooms. Surge protective devices, or SPDs, protect electrical equipment from voltage surges. The National Electrical Code recommends that SPD be installed in electrical panels and at individual equipment locations. Electrical panels are the main distribution points for electricity in a building. Electrical panels contain circuit breakers or fuses that protect individual circuits from overcurrents. Circuit breakers are reusable devices that trip and interrupt the circuit when an overcurrent occurs. Fuses are one-time devices that melt and interrupt the circuit when an overcurrent occurs. Electrical wiring must be properly supported and secure to prevent damage and ensure safety. The National Electrical Code provides guidelines for supporting and securing electrical wiring. Electrical boxes must be properly mounted and secured to prevent them from becoming loose or falling down. The National Electrical Code provides guidelines for mounting and securing electrical boxes. Electrical conduit is a protective raceway for electrical wiring. The National Electrical Code provides guidelines for installing and using electrical conduit. Flexible metal conduit, or FMC, is a type of flexible conduit that is often used for connecting electrical equipment. The National Electrical Code provides guidelines for installing and using flexible metal conduit. Liquid-type flexible metal conduit, or LFMC, is a type of flexible conduit that is used in wet locations. The National Electrical Code provides guidelines for installing and using liquid-type flexible metal conduit. Non-metallic conduit is a type of conduit that is made of plastic. The National Electrical Code provides guidelines for installing and using non-metallic conduit. Underground wiring must be installed in accordance with the National Electrical Code. Underground wiring must be buried at a sufficient depth to protect it from damage. The National Electrical Code provides guidelines for burying underground wiring. Electrical equipment must be properly labeled and identified. The National Electrical Code requires that electrical equipment be labeled with its voltage, amperage, and other important information. Electrical drawings are used to show the layout of electrical systems. Electrical drawings must be accurate and complete. The National Electrical Code requires that electrical drawings be available for inspection. Electrical calculations are used to determine the size of conductors, circuit breakers, and other electrical equipment. Electrical calculations must be performed accurately. The National Electrical Code provides guidelines for performing electrical calculations. The electrical troubleshooting is the process of identifying and resolving electrical problems. The electrical troubleshooting requires a thorough understanding of electrical systems. Electrical safety is the most important aspect of working with electricity. Always follow all safety precautions and wear appropriate personal protective equipment. Remember that electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Always disconnect the power supply before working on electrical equipment. Use a voltage tester to verify that the circuit is de-energized. Never work on electrical equipment while standing in water or on a wet surface. Wear insulated gloves and safety glasses when working with electricity. Do not overload electrical circuits. Use extension cords safely. Keep electrical equipment away from flammable materials. Have your electrical system inspected regularly by a qualified electrician. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these safety tips, you can help prevent electrical accidents and injuries. Remember, safety is always the top priority when working with electricity. The information provided in this narration is for general informational purposes only and does not constitute professional advice. Always consult with a qualified electrician or other professional before making any decisions about electrical work. The National Electrical Code is a complex and constantly evolving document. It is important to stay up to date on the latest changes to the code. The National Fire Protection Association, or NFPA, publishes the National Electrical Code. The NFPA website is a valuable resource for information about electrical safety. Many other organizations also provide information about electrical safety. By taking the time to learn about electrical safety, you can help protect yourself and others from electrical hazards. Remember, electrical safety is everyone's responsibility.